Okay, so here's a video review for Concept 9, the properties of quadrilaterals. So first, you're going to get some shapes, and you want to use only what's given to decide what the shape is and how you know. So in this first shape, for instance, it looks an awful lot like a square, but in fact, we don't know that it's a square. Right? There aren't markings that tell us the things we would need to see to have it be a square. All that's marked on this shape are these 4 90-degree angles, right? 1, 2, 3, 4. All of those angles are indicated to be 90 degrees. And so we have to use the definition that says all angles are 90 degrees. That is for a rectangle. So all we know about this shape is that it's a rectangle because it has 4 90-degree angles. So that's as specific as we can get. On this shape, again, we have to only use what's exactly given to us. These sides are parallel, but these are not indicated to be parallel. This is another kind of tricky diagram because it looks like these sides are the same, but it's not marked that way. So we actually don't know that these sides are the same, so we can't say anything about those sides. So this must just be a regular old trapezoid because it has one pair of parallel sides. And those are the opposite ones. And right, they're opposite each other. They're across from each other. Okay. So for this part of your concept, you want to pay very close attention to the markings that are there and only base your definition on what is given to you, not what it looks like, but what is actually marked and indicated. All right, now let's solve for some of these unknowns. So it says use properties to solve for the missing variables. Okay, so first I want to decide what shape is this and how do I know? The markings on this shape show me that all 4 sides are congruent. So since that's really all we know, this must be a rhombus because all 4 sides are congruent. All 4 sides are congruent. Okay. So since it's a rhombus, because all 4 sides are congruent, now we have unlocked all of the properties of a rhombus. One of those properties is that the diagonals are perpendicular, which means they intersect at 90-degree angles. That's really helpful because that means all of these angles are 90 degrees, including this one that says 3x. So first, I'm going to say 3x is equal to 90 degrees. When I solve for x, I get x is equal to 30. Pop those degree symbols off. Okay. So this is really helpful now because this angle is 2x. So now I can say that angle is 2 times 30, which is 60 degrees. This angle is, again, 90 degrees because it's one of the angles formed by the intersection of the diagonals. And so if I pulled that triangle out from the, if I pulled this triangle out and drew it over here, this angle is 60 degrees. This angle is 90 degrees because it's from the intersection of the diagonals, which means this angle must be 30 degrees. Since that's where y was, we can say that y is equal to 30 degrees. And remember, we're getting these numbers because a triangle has to add up to 180 degrees. So 90 plus 60 is 150, right? 90 plus 60 is a 150. And then 180 degrees minus 150 degrees leaves us with 30 degrees. So we solved for x. Let's put a box around that. We solved for y. We'll put a box around that. And I've got work showing how. But remember, we started with the fact that this was a rhombus based on the fact that our given information was that all four sides are congruent. All right, let's look at number 4. So it says in parallelogram ABCD. It's really important that it says parallelogram ABCD because stating that this is a parallelogram unlocks all of the properties of a parallelogram, right? There's nothing on here to indicate that this is actually a parallelogram, but now it's been named one, so we can use all those properties. So this says AT equals 4x minus 7. Well, AT is this side, or that chunk of the diagonal, that half of the diagonal. So let's label that as 4x minus 7. It also says that CT is negative x plus 13. So CT is negative x plus 13. Okay, so one of the properties of a parallelogram, so again, this is a parallelogram. Ooh. Wow, spelling. Let's try that again. So this is a parallelogram. Okay, so that's a parallelogram. So the property that we're going to use here is that the diagonals bisect each other. Diagonals bisect each other. Okay. This is helpful because that means this line cuts this line in half exactly. Bisect means to cut in half. So that means AT has to be the same length as CT, right? They're each half of the diagonal, so they're equal to each other. So to solve for x, we can say 4x minus 7 is equal to negative x plus 13. And now we just follow our equation solving to isolate x. So I'm going to start by saying plus 7 on both sides, and I get 4x is equal to negative x plus 20. Now I need to get all my x's on one side, so I'll add x, and I get 5x is equal to 20. Last but not least, we're going to divide by the coefficient on x and get x is equal to 4. Cool. So again, because this was defined as a parallelogram in the words, I could then use any of the properties of a parallelogram that would help me know more about my figure. There's a lot of properties about this parallelogram that we didn't use to solve this problem. We only needed the fact that the diagonals bisect each other because our x's were only involving that one diagonal. All right, let's keep going. So for 5 and 6, the question here says, what values must x and y have to make each of these a parallelogram? Well, let's just say these are parallelograms. Let's solve for x and y. So we are given that opposite sides are congruent, but then our x's and y's in this problem, for problem 5, they're really only about the angles. So the property of a parallelogram that we want to use is first that opposite angles are congruent. So that's what we're going to start with. Opposite angles are congruent. Now, it might look like this is a rectangle and that these are 90-degree angles, but we don't know that. They're not marked as 90-degree angles, and we weren't told that this is a rectangle. So we cannot make that assumption just because it kind of looks like it might be true. But what we can say, since opposite angles are congruent, is this angle is congruent to this angle, and for good measure, this angle is congruent to this angle, right? That's true. Now, these two aren't as helpful right now because this is completely unknown. We don't have any information there. But it is quite helpful that these two are congruent because we have information about both of those, and the only variable present in either of those angles is x. So, since those are congruent angles, that means they have the same measure and they must be equal to each other. We can then say 3x is equal to 2x plus 33. This is great because we have one equation, one variable, and we can solve for that variable. So we say minus 2x on both sides of our equal sign, and we get x is equal to 33. Now, we know that x is equal to 33. We can use that to help us solve for y. We're actually going to bring in another property of a parallelogram, which is that consecutive angles are supplementary. So remember, supplementary means that it adds to 180 degrees. So we know that this plus that needs to be 180, or you could do this plus that and make that 180. Doesn't matter which one, consecutive just means in a row. So if you pick an angle and then start going around the shape, the next angle you hit is the consecutive one. I'm going to choose these two because this doesn't have a plus sign in it, so it's one less step. So first I'll say 3x plus y is equal to 180. But we know x is 33, so I'm going to substitute in that 33 in place of x. That's handy because now again I have one equation with only one variable. 3 times 33 is 99 plus y is equal to 180. And then when we subtract 99 from both sides to get y by itself, we get y is equal to 81. I'm going to check that. Feeling like my mental math might be off. Nope, it's not. But again, always good to check. So y is equal to 81. Just to recap that, it wants to know what x and y have to be to make this a parallelogram. So we're going to go backwards and assume this is a parallelogram and then use the properties that are true for a parallelogram. The first property we used, since we were given information about angles, is that opposite angles are congruent. We did that because when we looked at our opposite angles, two of them, one pair of them, only has x's, so we were able to solve for x. Then we used the property that consecutive angles are supplementary, and we used our value of x to set up an equation saying consecutive angles, these two angles this time, are equal to 180. And then we subbed in our value, our known x, so that we could isolate y. Okay, so let's take a look at number 6. Again, this is still in the realm of what needs to be true about our variables to make this a parallelogram. So we're going to work backwards and say, assume this is a parallelogram. what properties can we use to then isolate x and y? Cool. So let's start with our side lengths here. So we can solve for y first this time because the property we're using is that opposite sides of a parallelogram, opposite sides are congruent. Well, that means they have the same length. So we can just say 13 is equal to negative 3y plus 1. And we isolate y using legal moves. Minus 1, minus 1. 12 is equal to negative 3y. To get one positive y by itself, we divide by its coefficient. And we get negative 4 is equal to y. That's it. Now, these angles, they are congruent, and you probably knew that. So this actually goes back to our work with parallel lines. If we think about these parallel lines, I'm gonna try and put that in the right spot here. If we think about that parallel line and this parallel line and this transversal, then these angles have to be congruent because they are alternate interior angles, right? Ring some old bells from first semester, because they are inside the parallel line, so they're interior, but they're on alternating sides of the transversal, hence alternate interior angles. Well, that's great. So alternate interior angles are congruent. So we can say 23 is equal to 3x plus 2. And then solve. Minus 2, minus 2. 21 is equal to 3x. Divide by the coefficient on x. And we get 7 is equal to x. That's it. Cool. Last few. So, in rhombus, JKLN. Okay, pause. We just got a lot of information and there's no diagram. Time to draw. So, I'm not a robot. This is not going to be a perfect rhombus, but I'm just going to label it as a rhombus by saying that all the sides are congruent. I'm also going to say, since it told me it's JKLN, this is J, this is K, this is L, and this is N. Right? You want to label in the order that you're given the letters and just go in one direction. Cool. So it tells us KL is 10. So let's add that to our diagram. This is 10. And since all the sides are congruent, I'm going to go ahead and just add those to be all 10. Our next piece of information is that the diagonal JL is 16. So I'm going to draw that diagonal in. And I know that that's 16, but I'm going to do this and draw my other diagonal and take this 16 and split it in half. So I know this part of JL is 8 and this part of JL is 8. Because diagonals in a rhombus bisect each other. Because diagonals in a parallelogram bisect each other. So we can split this 16 into 8 and 8. The reason I did that is now I can use some right triangle properties to find this length. So the reason I can use right triangle properties is because the diagonals of a rhombus are perpendicular. So now that's a right triangle. And I'm actually going to draw that triangle outside the rhombus so I can work with it a little more carefully. So I'll say, here's my right triangle. Close enough. It's labeled as a right triangle, so we'll go with it. This side is 8. This side is 10. So really, if I'm thinking about my labels, this would be K and this would be J. So this J and this J are the same. K and K are the same. So Now I need to use my Pythagorean theorem. A squared plus B squared equals C squared. I'm going to say my A is 8. So I'm going to say A squared plus B squared because I don't know what this side length is. That's what I'm solving for. Equals 10 squared. Then I just follow order of operations. 64 plus B squared equals 100. Subtract 64 from both sides. And I get B squared is equal to 36. To undo a square, you take the square root. That's the inverse operation. And we get B is equal to 6. Oh, it almost even looks like a 6 there. Cool. So I'm going to label this as 6. I'm also going to label that as 6 because they're congruent, right? If the diagonals bisect each other, then each half is the same. Now, quick note, I only need the positive 6 when I take the square root of 36 because this is a shape. It doesn't have negative side lengths. So if this side is the square root of 36, it has to be the positive 6. All right, so now we can answer our question. Find the length of NK. There's NK. We know that each half of it is 6, which means NK has to equal 12. Cool. So, biggest takeaway here is if a question talks about a shape but doesn't give you a picture, draw a picture. When in doubt, draw it out. All right. Last but not least, so we get to say hello to our old friend trigonometry on this one. The question is asking, what is the area and perimeter of this figure? We need to clearly show our steps and calculations. And it gives us a note. Figures are not drawn to scale. This is really important because you cannot eyeball this figure, right? We can't just say, well, this looks like it's most of it or half of it. Or no, we have to calculate everything. But first, this is, I don't know, it looks like a puppy when one ear is up and one ear is down. That's not really a helpful shape. We don't have a formula for this exact shape's area and perimeter. But we can break this into two shapes that we know a lot more about. So I'm going to look for where I can make some triangles. Triangles are the best shape. And so if I put a line there, now we have a rectangle and a triangle. So a rectangle has opposite sides that are congruent, right? Because that's one of our parallelogram properties that also applies to rectangles. So if this length is 22, this length also has to be 22. I'm going to cross this out for a second and just call this 22. And then since this was 64, I'm going to do 64 minus 22 and get that this length is 42. And so here's a check, right? This on this paper looks way bigger than that, but because of the way it's labeled, this is actually quite a bit smaller than that. And that's okay, we just run with that. So next, I need to know some things because for area, I need this area and that area. So I'll need this length to help me with my triangle area. But for perimeter, I'm also going to need this length and that length. So I'm just going to find all of those lengths first, and then I can answer everything sort of all at once at the end. Okay, and I'm going to do a little color coding here, surprising no one. So let's find this side first. Given that this is my angle, I'm going to label this is my hypotenuse, this is my opposite, and this is my adjacent, just to sort of help me keep the sides of the triangle in order with regard to the angle I was given. So I'm looking for the opposite. We'll just find that first. And I'll say, since I'm looking for the opposite and I have the adjacent, that's going to be tangent. Tangent is opposite over adjacent. So I'll say tangent of 50 degrees, make sure your calculator's in degrees, is equal to this unknown, right, the opposite, over the adjacent side, which is 42. To isolate my unknown, to find the length of the opposite, I'm going to multiply both sides by 42. And I'll get 42 tangent of 50 degrees equals my opposite side. Be very careful that the 42 is on this side of the tangent. We don't want to multiply the 40 with, or the 42 with the 50. The 50 is an input to a function. It can't interact with that 42 right now. But we can say 42 times tangent of 50, and we get 50.05 as our opposite length. So I am going to sneak that in here. So this is 50.05. Now I can actually find this length because I'm going to find that length because this whole length is 80, which means this whole length is 80. We know that this part of it is 50.5. So I'm going to do 80 minus that 50.05. Excuse me, I misspoke there. And I get that this orange length is 29.95. Because then these two things, those two lengths, will add up to 80. Okay, so we almost have everything we need. We still need to find our hypotenuse. Let's make that pink. Okay, so our hypotenuse here, I am going to use the 50-degree angle and the 42 side length because this is a rounded side length. It wasn't exactly 50.05, the decimals continued, but this was given to me as exactly 42, right, based on our subtraction. So it's a crisper number. I'm going to set up the same thing. We have adjacent and hypotenuse and an angle. Adjacent and hypotenuse, that means cosine. So we'll say cosine of 50 degrees is equal to our adjacent, which is 42, over the hypotenuse. Well, it's not as easy to isolate h in this case because our unknown is in the denominator. So we can follow just algebraic rules to isolate h, but what ends up happening is the cosine of the angle and the unknown in the denominator switch places. So that'll be h is equal to 42 over cosine of 50 degrees. Now we put that in a calculator, 42 divided by cosine of 50 degrees, and we get that it's about 65.34. So I'm going to write that over here, 65.34. Awesome. Now we have all the pieces and parts we need to find our area and perimeter. And I'm going to actually find them in the opposite order. So perimeter is all of the outside lengths added up. So we are not going to include that length. Even though we need it later for our area, we don't need it when we add up the side lengths for the perimeter. So we'll say this 65.34 plus 29.95 plus this 22 plus 80 plus, I'll say 22 plus 42 because I broke that up. And then we're back to where we started. Notice I picked a vertex and I just added the side lengths going around the shape clockwise. That's a helpful way to not forget any of your side lengths and to not double count anything. So when I do that, I get the perimeter is 261.29 meters, right? It's given meters, so my answer should have meters. I'm just going to double check that. 4 plus 80 plus 9 plus 65.34. Same thing, 261.29. So I think we're good to go there. For the area, I really need the area of this triangle and the area of that rectangle. So I'm going to find those separately. And I'll do the rectangle first. Area of a rectangle is base times height, or length times width. That, in this case, is just going to be 80 times 22. And that gives us an area of 1,760 meters squared, square meters, right? Because 80 times 22 and meters times meters. Then our area of this triangle, our area of a triangle, is equal to 1/2 base times height. So I'm going to fill that in. I'm going to say 1/2 times 50.05 times 42, right? 50.05 is my base, 42 is my height because they are at a right angle with each other. So 50.05 times 42 times 1/2 is equal to 1,051.05. And again, that's going to be meters squared. And I'm not going to write it in there because it's too small. But I need to add this to that because it's a composite shape. So I need both areas added together. And when I do that, I get an area of 2,811.05 square meters. And that's it. So when you're dealing with a composite shape like this, look for rectangles and triangles that you can break it into, or trapezoids sometimes are helpful too. And then work with each component separately. Don't make assumptions. You have to calculate it and use the indications given to you. If something's marked as congruent, awesome. If something's marked as 90 degrees, awesome. Use that. But don't make assumptions based on how it looks. I hope this was helpful. Happy studying, and we'll see you in class.